Hello and welcome to the final exam review for Calc 112. We're going to go through an old practice exam from fall 2019. Now this was the actual final for fall 2019, Calc 112. So let's start off with our first one. So our first problem here, part A, we have a, looks like a U substitution. So what we will do is we'll set our U to be x squared plus 1. Our du will be 2 dx, 2x dx. And we don't have the 2 there for our problem, so to make it look the same, we're going to divide by 2. So we have 1/2 du equals x dx. Okay, so let's go ahead and make our substitution. So we have integral 1/2 u, this would be u to the 1/2 du. And then when we integrate, we'll have the 1/2. The u to the 1/2 becomes u to the 3/2. We up the power. Divide by 3/2 or multiply by 2/3. Plus c. And now we can substitute back in. One minor thing we could do here, we could cancel out the 2's. So we have 1/3. Let's plug back in place of u. We have 1/3 x squared plus 1 to the 3/2 plus c. Okay, let's take a look at part B. In part B, what we could do is write this as a denominator. We could factor out an x. So we could say this is, I'm going to put the dx on the side, x times x plus 1. So I could rewrite this almost like a partial fractions problem. Okay, so let me focus on the partial fractions and I'll put it in terms of integrals. Okay, so for this fraction, we're going to say this is going to be split it up as a partial fraction, a over x plus b over x plus 1. Okay, so to solve this, we're going to multiply by x plus 1, top and bottom, on the left. On the right, we'll multiply this by x. That'll give us the common denominator. So what this means is if we look at the numerator, focus on the numerator, we have ax, and we could distribute the a here, ax plus a plus bx, and that's going to be equal to our original numerator here of 1. Okay, so now what does that mean? Well, we have a 1 there. There's no x's. That means ax plus bx is going to equal 0, or 0x. And then in terms of constants, we have a equals 1. So if a equals 1, that means b would have to be -1 for this statement to be true. Okay, so we have a, we have b. Now we can set up our integrals. Okay, so we'll have integral of 1 over x minus 1 over x plus 1 dx. And we could easily integrate this, so this would be ln of x minus ln of x plus 1 plus c. Okay, let's take a look at our next problem. It says use the disk method, okay, to find the volume. Okay, so if we do a quick graph on this, y equals the square root of 1 minus x squared, we will notice that the graph is actually a semicircle. It's a semicircle. It looks like this. Okay, so it's this solid that we're going to be revolving around about the x-axis. Okay, so if we remember back to our disk method, we would do typically integral from a to b of pi, and then the function our function squared dx. Okay, so here we'll be going from -1 to 1, pi square root of 1 minus x squared squared dx. Okay, so what's nice is the square and the square root will cancel each other. We could pull the pi outside. So we have pi -1 to 1, 1 minus x squared dx. Okay, and that means we could evaluate this, integrate this. We have pi, and when we integrate 1 we get x, and when we integrate x squared we get 1/3 x cubed. Okay, and now we evaluate. So plug in 1 minus 1/3 of 1 cubed minus, plug in -1, so this gives us 1 cubed is 1 times 1/3 is 1/3. 1 minus 1/3 would be 2/3 minus pi. And here we have -1/3 cubed is -1/3 times -1 times -1/3 is +1/3. -1 plus 1/3 will be -2/3. Okay, so, and then here this is going to turn to a negative minus a negative times a negative, so that's a plus. So we have 2/3 pi plus 2/3 pi, so 4/3 pi. Okay, so far so good. Let's take a look at number 3, part A. Okay, evaluate the integral of x e to the negative x. Okay, so this is going to be integration by parts. So for integration by parts, we have to pick the u and the dv correctly, right? So the idea is we're going to do uv minus integral of v du. Okay, so we're going to say that in this case, something that differentiates not quite nicely is the x. So u is going to equal x. Du will be dx, or 1 dx. And that would make dv equal to e to the negative x dx. I can easily integrate that. I get v equals negative e to the negative x. Okay, so let's do the formula. We got uv, so it'll be x times negative e to the negative x, so that'll be negative x e to negative x minus integral of v du, so that's negative e to the negative x dx. Okay, so now when we integrate that, we'll end up with negative x e to the negative x, and then minus e to the negative x plus c. Okay, let's take a look at part B. Alright, in part B we can do a u substitution here. We notice that we have secant squared and tangent squared. Keep in mind that the derivative of a tangent is secant squared. So if we keep that in mind, we would have our correct u substitution. So we'll say u equals tangent, and that would make du equal to secant squared x dx. Okay, so that means this is going to be our u. So we'll have integral of u squared du. Okay, so this means when we integrate it, we get 1/3 u cubed plus c. And so when we substitute back, 1/3 tangent cubed x plus c. And that will be the final answer for that one. Okay. Let's take a look at our next problem, number 4. Evaluate the following integrals. Okay, so for part A, what we could do is make a substitution for the sine squared, right? Sine squared, if you remember, sine squared of x, we could say is 1 minus cosine of 2x over 2. Okay, so we have integral of 1 plus 1 minus cosine 2x over 2. Okay, and that's going to allow us to integrate this a lot easier. Okay, so we get 1 plus, this will be 1/2 minus 1/2 cosine of 2x. You combine the 1 and the 1/2, so you have 3/2 minus 1/2 cosine 2x dx. Okay, when we integrate, we have 3/2 x and then minus, we anti-differentiate cosine, that's sine, but we have to account for the 2 when we do the chain rule, so that'll be 1/2, so I mean this will be 1/4 times the 1/2, 1/2 times the 1/2, that'll be 1/4 sine of 2x plus c. Okay, let's take a look at our next one. Okay, if we take a look at this one, we can easily separate out the numerator, make this into two integrals. Division, divide up the space. So we'll say this is going to be integral of 1 over 1 plus 4x squared dx minus integral of x over 1 plus 4x squared dx. Well, the one on the left, that fits the form of arctangent. Right? Arctangent, if we take the square root of 4x squared, it'll be 2x, right? So this will be, when we do the derivative, we'll do arctangent of 2x times the derivative of 2x, which is 2, so we would have another 1/2. Okay, so that means this would be 1/2 arctan of 2x. And then here, when we do this, this would be a ln. Right? This would be ln of the denominator. And then we would expect the 8 up here, which we don't have. So to offset that, we have a 1/8. So minus 1/8 ln of 1 plus 4x squared plus c. Okay, that would be the final answer for that one. Alright, let's take a look at the next problem. Find the first three terms in the Taylor series. Okay, so let's do our first three terms. We have f of x equals 1 plus x squared. F prime of x would equal 2x. And f double prime of x would equal 2. Evaluate each of these at a equals 1. So we have f of 1 squared plus 1 will be 2. F prime of 1 will be 2 times 1, which is 2. And f double prime of 1, that would be 2 automatically. Okay, plugging into our Taylor series formula. So this will be, first term is 2 plus 2 times x minus 1, right, because we're centered about a equals 1, plus 2 over 2 factorial of x minus 1 squared. Okay, and we can simplify that a little bit. So we would have 2 plus 2x minus 1, and then these 2's would cancel, plus x minus 1 squared. Okay, let's take a look at part B. Sum the following series. Okay, so we have 1 equals 0 to infinity. I'm going to split this up. So I have here 2 to the n over 5 to the n plus 1 plus 3 to the n over 5 to the n plus 1. Now what you could do to make this a little bit easier, on the denominator, that extra plus 1, you could pull out one of the 5's. You have an extra 1/5 here. Right? When you pull out the denominator, you have, here, let me just go like this. Right? You could write that one like that. And then the one on the right would be 5 times 5 to the n. So you basically have a 1/5 right? You could have a 1/5 you could pull out. And you could have this be 2/5 to the n, and then 1/5, and then make this 3/5 to the n. Okay, so they're both geometric series. We get a sum for both of them. Remember the formula for that. The sum would be the first term over 1 minus the common ratio, right? A over 1 minus r. Okay, so if we're going from 0 to infinity, that means our first term would be 1. Yes, we got 1 over 1 minus, right, because anything to the 0 power is 1. 1 minus the common ratio here would be 2/5. That would give you the sum for that one. Don't forget we're going to multiply by 1/5. And then here we got the 1/5. Again, to the 0 power that's a 1. 1 minus common ratio of 3/5. Okay, so inside the fraction, 1 minus 2/5, that's 5/5 minus 2/5 is 3/5. 1 over 3/5 is 5/3. And I got times the 1/5. And then here, I have 5/5 minus 3/5 is 2/5. 1 over 2/5 is 5/2. Okay, cancel out the 5's here, cancel out the 5's here. So I have 1/3 plus 1/2, which would make 2/6 plus 3/6 would equal 5/6. Okay, let's take a look at 6. Okay, we got this integral test. Okay, so let's do the integral test. So we got integral of 2 to infinity of 1 over x ln x dx. Okay, so if we do u is equal to ln x, that means du would equal 1 over x dx. Okay, so what does this mean for this? That means that this is going to turn into ln of ln x, right? Yeah, this will be ln of ln x. And remember the integral test we'll say is limit, we say b as b approaches infinity. And we already integrated, we said it's ln of ln x, ln of ln x. And we evaluate u2. Okay, so limit as b approaches infinity, ln of b minus ln of 2 okay, so as the limit of b approaches infinity, this is going to go to infinity, right? And this will just be a small number, infinity minus a small number. Okay, so we would say that this one diverges. Okay, part B, comparison test. Okay, so I could use a limit comparison test. I'm going to say that I'm looking at this, my Bn, I'm going to say is going to be 1/2 to the n. Okay, so I'm going to take limit as n approaches infinity of 1 over n, 1/2 to the n, and this is going to be our a sub n. Right. So we have that over b over n, b sub n, okay. So we got, these would cancel. So we have limit n approaches infinity of 1 over n. Okay, and as n approaches infinity, this becomes 0. And so what does this mean? This means that if Bn converges, then An will also converge. Okay, so therefore our series here, An converges. Okay, and this would be by the limit comparison test. Okay, so let's take a look at our next problem. Use the ratio test. Alright, so ratio test would be limit as n approaches infinity of a sub n plus 1 over a sub n. Okay, so let's do that. We have limit as n approaches infinity, and we have so we have 2 to the n plus 1 over n plus 1 factorial times n factorial over 2 to the n. Okay, so now when we rewrite this, this will be 2 times 2 to the n over n plus 1 times n factorial times n factorial over 2 to the n. Okay, so 2 to the n's will cancel, n factorials will cancel. We have just 2 over n plus 1, and when we take limit as n approaches infinity, denominator will grow, this will go towards 0, and this limit of 0 is less than 1, so therefore this series converges. Absolute. Okay, part B, use the root test. Okay, so let's take a look at the root test. So for this one, the root test, we take the limit as n approaches infinity. We would take the nth root of the absolute value of a to the n. So that would be absolute value of 1 plus n over 1 plus 2n to the nth power. Okay, so the nth root and the nth power, they will cancel. So we will be left with limit as n approaches infinity of 1 plus n over 1 plus 2n. And then we could divide everything by n. Divide by n. This goes to 0. this goes to 0, and we're left with here, this is 1, and this is 2. We get 1/2. Now 1/2 is less than 1, which means that this therefore converges absolutely by the root test. Okay, let's take a look at the next one. Number 8a. Determine whether the following suit converges. State which test. Okay, so for this one, we could try the nth term test. Okay, nth term test. So this is where we take the limit as n approaches infinity. We would say that the series diverges if this limit fails to exist or is different from 0. Okay, so let's take the limit as n approaches infinity of 1 plus n squared over 1 plus 10n squared. So if we divide everything by n squared, this will go to 0, this will go to 0, this becomes 1 on top, and this becomes 10 on the bottom. So this is different from 0, right? 1/10 is different from 0, so therefore we would say that this series converges, diverges. Got carried away there. Diverges by the nth term test. Okay, 8b. Determine the radius of convergence and interval of convergence for the power series. Okay, so we're going to use the ratio test here. Okay, so that means, we take the limit of as n approaches infinity, so we would have absolute value an plus 1 over an, so this would be 2x to the n plus 1 over n plus 1 cubed times, flip the an, so that would be n cubed over 2x to the n. Okay, so for the numerator we could rewrite this as 2x times 2x to the n. And we have n plus 1 cubed, n cubed, 2x to the n. Okay, so what we have here is the 2x to the n will cancel. So we're going to have the 2x, and then we'll have n cubed over n plus 1 cubed. Okay. Well, as the limit of n approaches infinity, we have an n cubed at the bottom here, and an n cubed on the top, so these are going to be canceling to 1. And then we'll be left with basically absolute value of 2x. Okay, so we have absolute value of 2x, and this will converge when this is less than 1. Okay, so that means when we're going to solve this, we'll have 2x is less than 1, which is less than -1 divided by 2. So that means x will be greater than negative 1/2 and less than 1/2, which tells us that the radius is going to be 1/2. Okay, now let's test the bounds, the endpoints at negative 1/2 and positive 1/2. Okay, so let's plug into the original series. So we have absolute value of 2 times negative 1/2 to the n over n cubed. Well, this becomes 2 times negative 1/2 would be negative 1. Okay, this will be alternating, and as n gets larger and larger, this is going to go towards 0. Right, so this converges. Okay, so this one converges. And then when x is 1/2, this just becomes 1 to the n over n cubed. And so this just converges again, right? This will just be like a p series. This also converges. So therefore, for our interval, we would have the including at the negative 1/2 and including at the 1/2. So negative 1/2 to 1/2. Square brackets around both, and that would be it. Okay. Let's take a look at our next problem. 9a and b. Evaluate the following integrals. A is an improper integral. So we have from, we're going to do a limit to this, right? Because when we plug in 1, we get the denominator to be 0, so undefined. Okay, so therefore improper integral. So we're going to say limit as b approaches 1 from 0 to b of 1 over square root of 1 minus x dx. Okay, so we're going to state like a u substitution. U would equal 1 minus x, du would equal negative dx. So that means we would have here limit as b approaches 1. This would be u to negative 1/2, and then this would be negative du. Right. Okay, so we have a limit as b approaches 1. We could integrate this easily. This will be added power, so we have u to the 1/2 divided by 1/2, which is multiplying by 2. And then we have the negative from du, so we got negative 2 u to the 1/2. Okay, and now we could plug back in. Limit b approaches 1. We got negative 2. We can do square root 1 minus x. And we evaluate from b to 0. Okay, so we got limit as b approaches 1. Plug in the b. We have negative 2 square root of 1 minus b minus negative 2 square root of 1 minus 0 Okay, so as b gets closer and closer to 1, this radical gets closer and closer to 0. So 0 times anything will be 0 minus, and then here square root of this becomes square root of 1, which is 1. So we have 1 times negative 2 is negative 2. So final answer here will be 2. Okay, let's take a look at part B. Okay, part B is going to bring us way back. We're going to go to trig substitution here. Okay, you have to recognize the form. So for the trig substitution, the denominator gives it away, the square root of 1 minus x squared. That's going to be the triangle that looks like this. So if we have theta here, and we have x here and 1 here, the cosine is going to be 1 minus x squared. Okay, so we're going to say that x is equal to, it's generally a sine theta, but this will just be 1. So ax equals sine theta. And then that would make dx equal to cosine theta d theta. Okay, so that means for our integral, when we do the substitution, we have sine cubed theta on top, and in the bottom that would be the cosine theta, and then d theta, or the dx I should say, dx will be cosine theta d theta. Okay, now right off the bat, the cosine here and the denominator with the cosine here, they cancel each other out. Okay, so that means we have integral of sine cubed theta d theta. Let me see, I have room. I'm going to create some room down here. Okay, so bring this down here. So we have integral sine cubed theta d theta. Okay, so that means we could split this up and say that this is equal to sine theta times sine square theta d theta. And that means we could say this is sine theta times 1 minus cosine squared theta d theta. And so if we distribute the sine, right, we would have sine theta minus cosine squared sine theta d theta. And now we could integrate this, so we have negative cosine theta Now, derivative of cosine would be negative sine, so this is going to turn the minus into a plus. This would be 1/3 cosine cubed theta plus c. And then we go back and plug in for our original x's. So cosine theta was square root of 1 minus x squared, and then 1/3 1 minus x squared, and it was a square root, right, for the cosine, so that means this would be to the 3/2 power plus c. And this will be the final answer for that one. Alright, let's take a look at the last one. Find the area of the polar region lies inside r equals 4 cosine theta and outside r equals 2. Okay, so when we graph this, r equals 2 is our circle centered at the origin with a radius of 2. Okay, for r equals 4 cosine theta, that's the circle that's lying on the x-axis, if you will. Has a diameter of 4. It's centered at 2, 0. So it'll be centered here. It'll have a radius of 2. Okay, so basically we're looking at, we'll do this, something that stands out. We have this region. What I'll do is I'll figure out this region, and because the bottom is the same, this is a symmetric graph, I'll take this region and I'll double it. Okay, and that'll be the whole region here. So it's outside r equals 2, but inside r equals 4 cosine theta. Okay. So what we need to do first is figure out what the angles are from where we are calculating. Okay. So I set the two equations equal. I'll say that 2 is equal to 4 cosine theta. Divide by 4. So I have 2 over 4 equals cosine theta. So cosine of theta equals 1/2. So what's theta going to be? It's going to be pi over 3. Okay, so pi over 3. So we'll go pi over 3 to 0. We won't even go pi over 3 to negative pi over 3. We'll go pi over 3 to 0, and then we'll double it. Okay, so to set it up, we got, because I'm doubling it up, I have my 2 outside, integral from 0 to pi over 3. Formula is 1/2 r squared. Now here I got my outer minus my inner, so I have my my 4 cosine theta, that's going to be the outer one, and then the inner one will be the r equals 2. Okay, so we got 1/2 4 cosine theta squared minus 2 squared d theta. Okay, when I pull the 2 outside, the 2 and the 1/2, they're going to cancel. Okay, so I got to square the 4 cosine. So that means I'll have 16 cosine squared theta minus 4. Okay, now the cosine squared, I'm going to substitute for the cosine squared. Remember, cosine squared theta is equal to 1 plus cosine of 2 theta over 2. Okay, 2 times 1/2, it cancels. So I have 16 times 1 plus cosine of 2 theta over 2 minus 4. Okay, that means if I pull out the 1/2, that'll make it 8. 8 will distribute, so I'll have integral 8 plus 8 cosine 2 theta minus 4 d theta. Okay, so my 8 and my minus 4, they will combine. So 8 minus 4 is 4. So I have integral pi 0 to pi over 3, 4 plus 8 cosine of 2 theta Okay, now I'm ready to integrate. So when I integrate, I have 4 theta, and then integral of cosine is sine. So the only way I get the 8 there is if I start with a 4 sine of 2 theta and now I could plug in my pi over 3. So I have 4 times pi over 3 plus 4 times sine of 2 times pi over 3, okay, minus 4 times 0 plus 4 times sine of 2 times 0. Okay, well, the sine of 2 times 0 is 0, sine of 0 is 0, 4 times 0 is 0, so the second part is 0. So we're left with 4 pi over 3 plus, now, sine of 2 pi over 3, sine of 2 pi over 3 is radical 3 over 2. And that means we have 4 pi over 3 plus, cancel between the 2 and the 4. So 4 pi over 3 plus 2 radical 3. And that would be the final answer. Okay, if you have any questions, bring it up during the lecture or just write me an email. Okay, hope you are able to use this to study off of. I'll see you soon. Have a good night, a good day. See you in class.